Nanotechnology is the science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. With nanoscience and nanotechnology, scientists are able to see and control individual atoms and molecules. Atoms make up everything on Earth, from the food we eat and the clothes we wear, to the buildings and houses we live in. In addition, the fact that a majority of biological processes occur at the nanoscale gives scientists models and templates to imagine and construct new processes that can enhance their work in medicine, imaging, computing, printing, chemical catalysis, material synthesis, and in many science fields, such as biology, physics, and engineering. The ideas and concepts behind nanoscience and nanotechnology started with a lecture entitled "There's Plenty of Room at the Bottom" on December 29, 1959, by physicist Richard Feynman at an American Physical Society meeting at the California Institute of Technology, long before the term nanotechnology was used. In his talk, Feynman described a process in which scientists would be able to manipulate and control individual atoms and molecules to essentially create whatever they could want. Feynman is quoted for saying that the principles of physics, as far as I can see, do not speak against the possibility of maneuvering things atom by atom. It is not an attempt to violate any laws of physics. It is something, in principle, that can be done. But in practice, it has simply not been done because we are too big. And over a decade later, in 1974, Professor Norio Taniguchi of the Tokyo University of Science finally coined the term nanotechnology through his explorations of ultra-precision machining. Now that we know some history, just how small is nano? In the International System of Units, the prefix nano means 1 billionth, or 10 to the negative 9th. Thus, 1 nanometer equals 1 billionth of a meter. It is difficult to imagine just how small this is, so here are some examples. A standard sheet of paper is about 100,000 nanometers thick. A strand of human DNA is 2.5 nanometers in diameter. There are 25,400,000 nanometers in 1 inch. A single human hair is approximately 80,000 to 100,000 nanometers wide. A single gold atom is about a third of a nanometer in diameter. On a comparative scale, if the diameter of a marble was 1 nanometer, the diameter of the Earth would be about 1 meter. And 1 nanometer is about how long your fingernail grows every second. You may be wondering, if these particles are so small, how could they possibly be created? The main way that nanoparticles and nanomaterials are created is through nanomanufacturing. This involves the scaled-up, reliable, and cost-effective manufacturing of nanoscale materials, structures, devices, and systems. Structures and properties of materials can be improved through these nanomanufacturing processes. With nanotechnology, materials can be altered to be stronger, lighter, more durable, water-repellent, anti-reflective, self-cleaning, ultraviolet or infrared resistant, anti-fog, antimicrobial, scratch-resistant, or electrically conductive. Recent leaps in areas such as microscopy have given scientists new tools to understand and take advantage of phenomena that occur naturally when matter is organized at the nanoscale. Essentially, the phenomena of nanoscale particles and materials are based on quantum effects, affected by other simple physical effects such as expanded surface area that occurs at the nanoscale. When particle sizes of solid matter in the visible scale are compared to what can be seen in a regular optical microscope, there is little difference in the properties of the particles. But when particles are created with dimensions of about 1 to 100 nanometers, where the particles can be seen only with powerful specialized microscopes, the material's properties change significantly from those at larger scales. This is the size scale where so-called quantum effects rule the behavior and properties of particles. One of the most powerful results of these quantum effects of the nanoscale is the concept of tunability of properties. That is, by changing the size of a particle, a scientist can literally fine-tune a material property of interest. Physical and chemical properties of nanomaterials that may change at the nanoscale include color, melting temperature, crystal structure, chemical reactivity, electrical conductivity, magnetism, and mechanical strength. By taking advantage of the implementation of extremely small particles and systems, today's nanotechnology can affect a vast variety of products. These can include tennis ball cores to prolong the life of the product. Tennis rackets using carbon nanotube infused titanium has been compounded in order to produce the lightest possible tennis racket, weighing less than the tennis ball. High efficiency and low-cost solar cells can be produced by simply printing nanoparticles and systems onto spools of cheaper metal foil. Special filters and processes which allow nanoparticles to bind to pollutants are the basis for new developments and pollution remediation. Even high-factor sunscreen, which is clear, not white, is due to the use of nano-sized titanium dioxide and zinc dioxide in sunscreen and moisturizers, and is one of the largest uses of nano in the cosmetic and personal care markets. Nanoscale transistors may also someday lead to computers that are faster, more reliable, and more energy efficient than those used today. Nanotechnology is more than just mixing nanomaterials together. It requires the ability to understand and to precisely manipulate and control those materials in a useful way. Nanotechnology involves a new and broad science where diverse fields such as physics, chemistry, biology, material science, and engineering converge at the nanoscale.